Can you simplify tricky irrational number radicals in algebra? Have you ever wondered if you can simplify those tricky irrational number radicals in algebra? Well, you are in for a treat. Let's break it down step by step. First, let's clarify what an irrational number radical is. It often involves the square root or other roots of a number that cannot be expressed as a simple fraction. For instance, the square root of 2 is irrational because it cannot be written as a ratio of two integers. These radicals pop up in algebra when solving equations or simplifying expressions. To simplify these radicals, you start by looking at the radicand, which is the number inside the radical symbol. The first step is to factor the radicand into its prime factors or into a product of perfect squares and other factors. For example, if you want to simplify the square root of 50, you can factor 50 as 25 times 2. Since 25 is a perfect square, you can take its square root out of the radical. This means the square root of 50 equals the square root of 25 times 2, which simplifies to 5 times the square root of 2. Next, you want to ensure that the radicand has no perfect square factors other than 1. This means you keep factoring and pulling out perfect squares until none remains inside. For instance, the square root of 72 can be factored as the square root of 36 times 2, which simplifies to 6 times the square root of 2. Now, what if you find a radical in the denominator of a fraction? You will want to rationalize the denominator. This means rewriting the expression so that the denominator is a rational number without any radicals. For example, if you have 1 divided by the square root of 3, you can multiply the fraction by the square root of 3 over the square root of 3. This gives you the square root of 3 divided by 3. When it comes to adding or subtracting radicals, you can only do this if they have the same radicand, which are called like radicals. For example, 3 times the square root of 2 plus 5 times the square root of 2 equals 8 times the square root of 2. Always simplify each radical first to identify like radicals. Multiplying radicals is also straightforward. You multiply the coefficients, which are the numbers outside the radicals, and then multiply the radicands inside the radicals separately. After that, simplify the resulting radical. For example, the square root of 3 times the square root of 12 equals the square root of 36, which simplifies to 6. Lastly, if you have variables with exponents inside radicals, you can use exponent rules to simplify. For instance, the square root of x raised to the 4th power equals x squared because the square root is the same as raising to the 1/2 power. Simplifying radicals is essential when solving quadratic equations with irrational solutions or working with radical expressions. It makes expressions easier to manage and understand. By following these clear methods, you can confidently simplify even the trickiest irrational number radicals, making algebra much more approachable.